Bismillahirrahmanirrahim. In the name of Allah, the most beneficent and the most merciful. My name is Dr. Afsheen and I am working as Associate Professor in School of Dentistry, Shahid Zulfikar Ali Bhutto Medical University. I did my MPhil in Dental Materials from Rifa International University where I was awarded with the gold medal for my research. Currently, I am a PhD scholar in ICAZ-2022 University. Today, I am going to elucidate and shed some light on the topic of current and worldwide interest, titled Mechanical Strength of Novel Dental Restorative Material Incorporating the Titanium Oxide Nanoparticles Synthesized by the Bacillus subtilis. Let's have an overview of the current study. In the first step, the synthesis of titanium oxide nanoparticles utilizing the Bacillus subtilis will be carried out. In the second step, the characterization of these synthesized titanium oxide nanoparticles by using the standardized protocols will be done. In the third step, the mechanical strength of the titanium oxide nanoparticles incorporated in the dental restorative material will be done. Let's talk about the nanotechnology. Nanotechnology is derived from a Greek word, nanos, which meant dwarf because it works at the level of atoms and molecules. The size of the particles ranges between 1 to 100 nanometers in the nanotechnology. The nanotechnology is a highly emerging field currently because it is lighter, stronger, faster, more durable. That's why it is highly recommended in the medical and dental applications. Now, what is nanodentistry? The incorporation of nanoparticles in diagnosis, monitoring, control, prevention, and treatment is known as nanodentistry. Let's talk about the synthesis of nanoparticles. There are three basic routes of the preparation of nanoparticles worldwide. These are physical, chemical, and biological. The physical methods incorporate the utilization of tube, furnace, ceramic heater, ball milling, and laser ablation. On the other hand, the chemical methods utilize the sol gel, solvothermal, and precipitation methods. Last but not the least, biological methods incorporate the natural resources such as microorganisms and plants. Here the question arises, why is biological method considered as the best option for the synthesis of nanoparticles? The answer to this question is that the nanoparticles prepared by this route are easily available, eco-friendly, sustainable, non-toxic, cost-effective, and safe. That's why they are highly recommended for utilization in the medical field. Why is this study paramountly indispensable and cannot be ignored? There is a deficiency of cost-effective, biosafe, and biocompatible titanium oxide nanoparticles in the current era to be utilized in the dentistry. The aim of the current study is to develop a cost-effective, biocompatible, and biosafe novel dental restorative material with enhanced mechanical strength. This aim will be attained by carrying out the three main objectives: to synthesize the titanium oxide nanoparticles by Bacillus subtilis, to characterize the titanium oxide nanoparticles prepared by the Bacillus subtilis, and to incorporate the titanium oxide nanoparticles in the dental restorative material to produce a novel dental restorative material with enhanced mechanical strength to treat the dental caries. Let's talk about the basic methodology design. In the first step, the Bacillus subtilis will be incorporated to produce the titanium oxide nanoparticles. In the second step, these titanium oxide nanoparticles will be characterized by utilizing the X-ray diffraction spectroscope, diffuse reflectance spectroscope, atomic force microscope, scanning electron microscope, energy dispersive X-ray spectroscope, transmission electron microscope, and Fourier transform infrared spectroscope. At the end, these titanium oxide nanoparticles will be incorporated in the conventional dental restorative material to produce a novel dental restorative material, and then its mechanical strength will be tested by utilizing the universal testing machine. Let's talk about the basic methodology of the synthesis of titanium oxide nanoparticles. First of all, the Bacillus subtilis culture and nutrient broth of 100 ml will be taken. After that, the diluted culture solution will be kept and grown for 24 hours. After 24 hours, 80 ml of the diluted culture solution and 20 ml of titanyl hydroxide will be mixed and heated at 60 degrees centigrade for about 20 minutes. After 20 minutes, this solution will be kept in a shaking incubator at 28 degrees centigrade for about 24 hours. After that, this solution will be dried at 80 degrees centigrade for next 24 hours. After the drying, the titanium oxide nanoparticles will settle down at the bottom of the flask in the form of the powder, which will be calcined at about 450 degrees centigrade for 3 hours in a furnace. After that, the pure crystalline form of titanium oxide nanoparticles will be attained. Let's comment something about the results. The first result which is visually observed is the color change, which shows the preparation of titanium oxide nanoparticles. All of you can very well see that in the figure A, the solution is yellowish in color, which is the Bacillus subtilis culture solution with titanyl hydroxide. And in the figure B, you can see the preparation of the titanium oxide nanoparticles by the change in color to pure white. The X-ray diffraction analysis shows the mixture of the anatase and rutile phases, which shows that these titanium oxide nanoparticles are highly biocompatible because the mixture of the rutile and anatase phase are considered safe in the literature. The UV-based diffuse reflecting spectroscopy confirmed the formation of large particle size because the band gap energy value is less. As the literature says that if the band gap value is less than the standard value of 3.2, then the size of the particles is larger. The atomic force microscope results totally confirmed that these titanium oxide nanoparticles are smooth, having soft surface. That's why they can be easily incorporated and mixed in the dental restorative material. The scanning electron microscopy results confirmed the spherical shape of the nanoparticles with a large size, which you can also see in this SEM picture. The energy dispersive X-ray spectroscope totally showed the pure peaks of titanium and oxygen without the involvement of any other impurity. Now, the transmission electron microscope results are totally in collaboration with the SEM and the TEM results because the size of the nanoparticles are quite large. The Fourier transform infrared spectroscope showed the presence of the functional groups which were safe from any sort of impurity and totally biosafe and biocompatible in the nature. All these results of characterization totally confirmed that the titanium oxide nanoparticles were biosafe and biocompatible to be utilized in the dentistry. Now, in this step, we will describe how the mechanical strength of this novel titanium oxide incorporated dental restorative material was enhanced. In this bar graph, you can easily see that the control group having no titanium oxide nanoparticles elaborates the low value of the strength as compared to the experimental group where the flexural strength is enhanced. In this next slide, the compressive strength analysis was done where again the control group without titanium oxide nanoparticles elaborates the lesser value as compared to the experimental group that was having the titanium oxide nanoparticles. It completely shows that the mechanical strength of the novel dental restorative material containing the titanium oxide nanoparticles was enhanced as compared to the conventional dental restorative material without titanium oxide nanoparticles. Now let's talk about the conclusion of the current study. The current study concluded that the novel dental restorative material containing the titanium oxide nanoparticles synthesized by the Bacillus subtilis were cost effective, biosafe, and biocompatible with enhanced mechanical strength, thereby ensuring the longevity of the restoration in the oral cavity. And this novel dental restorative material can easily treat the dental caries quite effectively and efficaciously for the longer duration. These are the references of the current study. Thank you very much, and Allah Hafiz.